In solving a quadratic, it's frequently the case that we're unable to factor it in our heads. So there are other ways that we can solve a quadratic. Before we solve one, let's first go over a couple of things and talk about the square root property. All right, if x squared is 16, then what's x equal to? Well, you might say 4, but in reality, it can be 4 or negative 4. Because if you square 4 or if you square negative 4, in both cases you get 16. Well, in general, let's write what's called the square root property. I'll refer to it as SRP. Let's say u and k are both positive numbers. Let's say k is a positive number. And if u squared is equal to k, then what do we know about u if I wanted to solve for u? It would be plus or minus radical k. That is the square root property that we will use throughout this class. And really, we did just the same thing we did up here. X is equal to plus or minus radical 16, which is plus or minus 4. All right, well, let's solve a simple equation using the square root property. Well, in order to use the square root property, we have to have something on the left or on one of the sides that is squared. And the whole thing has to be squared. So notice the 3 is not squared. Only the x is being squared. So we want to divide both sides by the 3. And that's going to give us x squared equals, and 27 over 3 is 9. Now we have a nice simple problem. Using the square root property, SRP, that gives us that x is equal to plus or minus radical 9, which we all know what radical 9 is 3, so I will say x equals plus or minus 3. That's the solution, and we use the square root property. Now, let's use the square root property to solve a quadratic. It may not be obvious that this is a quadratic equation, but it is. If you multiplied this out, you would end up getting an x squared term. But we're not going to do that. We're going to instead use the square root property, which means we want to get this term that's being squared all by itself on one side. So I'm going to have to add 49 to both sides. And that gives us x plus 3 squared equals 49. So this is an equivalent equation to the one that was given to us. Now we have it in the correct formula. In the correct form. U squared equals k, where k is a number, and the entire expression on the left-hand side is being squared. That's exactly what we have here. Something squared is equal to 49. Well, that tells us then, using the square root property, that x plus 3, this portion, is equal to plus or minus radical 49. That was the square root property in use, right there. Now we will subtract 3 from both sides, and we're going to get x all by itself. It's going to be negative 3 plus or minus radical 49 is 7. But this is our answer, but we can easily simplify that. X equals negative 3 plus 7 and negative 3 minus 7. So negative 3 minus 7 is a negative 10. Negative 3 plus 7 is a 4. And that's our solution to this quadratic equation using the square root property. Okay, that's the last example for the square root property. It's very simple. Now we're going to look at the third method for solving a quadratic. It's the least favorite, but we will be using this again later in the semester. It will be necessary. We're going to solve this quadratic by completing the square. So the first thing we want to do is identify what A, B, and C are in this left side. After you get 0 on one side, get it written in this standard form and identify A, B, and C. Remember, this is ax squared plus bx plus c. So I can say A is 1, B is 4, C is 1. And note that A needs to be a 1 in order to complete the square. If it's not a 1, it's very simple to fix. If this were 3x squared, we would simply divide every term by 3. Both sides we divide by 3, and we would have x squared with a coefficient of 1. Now, let's subtract c from both sides, this term right here. What I want is the x squared plus 4x all by itself on one side. Okay, and here's what I'm going to add. Whatever you add to one side of an equation, you have to add to the other side of the equation as well. What is that magic number that I add that will make this a perfect square? Well, you just have to go to the coefficient of the x, which is the number 4, which is actually b, right? That's the b. Divide it by 2 and square that number. So we're going to add 1/2 of b squared to both sides. Let me just make a note that 1/2 b quantity squared is 2 squared, which is 4. So I'm going to add a 4 to both sides. Maybe I'll use a different color pen here. Add the same thing to both sides, and that same thing happens to be 1/2 b squared. So that gives us now x squared plus 4x plus 4 equals 4 minus 1 is 3. Now let's get 0 on one, I'm sorry, let me rephrase that. Now what we've done is the hard part. We already did the hard part. This left-hand side is now a perfect square binomial. It's a binomial squared. What would I have to square to get x squared plus 4x plus 4? Isn't that x plus 2 squared equals 3? By adding 4 to both sides, we created a perfect square binomial on this side. Or this is a trinomial. It's the square of this binomial, 2 terms. And x plus 2, you could FOIL it out, and you would get this side, get this value here. Okay, now we use the square root property to solve this. So, I'll rewrite it. X plus 2 squared equals 3. The square root property gives us the following. This, without the square, is equal to plus or minus radical 3. And one more step and we're done. I'm going to subtract 2 from both sides. X equals negative 2 plus or minus radical 3. And that's the solution using the completing the square method, which we'll use again in the next video.